Okay, welcome everyone. So we've got decision maths. Now this should have been June 2021. As you know, we had teacher assessed grades. So this is the most recent paper we have on decision 1. And as we know from this, we've figured out some people can't count to 10. Some people don't know how to add. And it was a bit of a tough question because some people also didn't know how to use a calculator and to read properly. That's all right though, it happens to the best of us. So what we are going to do is to go through it, and we're going to discuss the mark scheme as we go through this. So question 1, nice and easy. We're looking at this question straight away without reading it. We're thinking quick sort or bubble sort, okay? And we know whenever we have a quick or bubble, there's probably a bin packing involved. Yeah? So question 1, it says the numbers in the list represent the weights in kilograms of 12 parcels. The parcels are to be transported in containers that will each hold a maximum weight of 45 kg. Calculate a lower bound for the number of containers needed. You must make your method clear. So it says make your method clear. I am expecting you to write all of them added together. Some of you did not do this, that's okay. Because what it was actually in the mark scheme wanted was the total of this. Divide that by 45. So what was this? This was 177 divided by 45. Now some of us didn't write that. We just wrote the answer. But because they'd written this one at the top, they still got that mark. And then that actually equaled 3.9 something. We've then rounded that up to say 4 containers are needed. Okay, so that one was nice and simple, and that's a nice easy 2 marks, probably the nicest easiest 2 marks. It then says use first fit bin packing algorithm to allocate the parcels. Okay, so we know from the previous question that 45 is our one. So if we think about A, B, C, D, okay? So we know there's 45 in each note 1. Now I'm not suggesting you write this. Some of us can count 45 in our heads and some of us can't, okay? Turns out some of you need to write this. Okay, so remember it's first fit, so we start at the beginning. So 16. If I put 16 in here, I have 29 left, okay? 23 will fit in here. I have 6 left. 18 goes into the next one. That means I've got 27 left. Okay, then 9 can go in here. That'll mean I'll have 18 left. 4 can also go in here, and I'll have 14 left. 20. Oh, absolutely. Look, I've just made a mistake there. Can you see I was on a roll? 4 can actually fit in the first one, then there's 2 left, okay? Do you see how easy that was for me to make a clear little mistake, even though I can count? Okay, make sure you watch out for these numbers. Right, 20 has to go in the third one. Doesn't fit in the first one or the second one, has to be in the third one. It's 25 left. 35 does not fit in 2, 18 or 25. Has to go in this one, and that means there'll be 10 left. 5, does it go in the first one? No. Second one? Yep, and what's left? 13. 17. Third one? And there is 8 left over. 13. Goes in the second one. That one's full. 6 has to go in the third one, and there is 2 left, and then 11. Okay, guys, 11 doesn't go in any of them. So we can see here we've got 5 bins. You have to get that fully correct for the 3 marks. Do we understand? There's no messing around here. Okay? Right. Then number C says, carry out a bubble sort starting at the left-hand side of the list, blah, blah, blah. Produce after, and it wants it in descending order. What does descending mean, first of all? Biggest to smallest. Okay, so step 1, we're going to write the list out. 16, 23, 18, 9, 4, 20, 35, 5, 17, 13, 6, 11. Now, guys, if you don't have 7 passes, you don't get the full marks here. So now that we do this list, I'm just going to move it here so we can see. Okay, so this is the list. After the first pass, I want biggest first, yeah? So 16 and 23. 23. 16 and 18. 18. 16 and 9. 16. 9 and 4. 4 and 20. 4 and 35. 4 and 5. 4 and 17. 4 and 13. 4 and 6. 4 and 11. 4. Brilliant. Guys, this is the first pass, okay? We're going to do that the whole time. So, which one is guaranteed to be in the correct place after the first pass? Yeah, the one at the end of the list on the right-hand side, yeah? Okay, so now, 23 and 18. 18 and 16. 16 and 9. 9 and 20. 9 and 35. 9 and 5. 5 and 17. 5 and 13. 5 and 6. 6 and 11. No, 5 and 11. 5. Brilliant. Second pass. Okay, it's so much easier to do it in your head than out loud. Right, now remember we only got it in the mark scheme, it says there's 7 passes. Okay, so next. 23 and 18. 18 and 16. Oh, 18. 16 and 20. 16 and 35. 16 and 9. 9 and 17. 9 and 13. 9 and 6. 6 and 11. 6, and then that's in the 6. So that's the third pass. Please make sure, because I did mark these very fast. Can you make sure each line looks like this? I may have to take marks off you, I may have to add them. Okay, you're also double checking this is right. Okay, fourth pass. 23 and 18. 18 and 20. 18 and 35. 18 and 16. 16 and 17. 16, 13. 13, 9. 9, 11. 9. Exactly. Okay, that's the fifth pass. 23 and 20. 20 and 35. 20 and 18. 18 and 17. 17 and 16. 16. 13. 11. 9. 6. 5. 4. Did we do any swaps there? Yes. Guys, we haven't finished yet. We've got to do one more. The sixth one. 23, 35. Then 23. And then we know that this is all right. But guys, the bubble sort does not stop. Well, we know, when does it stop? When there's no passes when there's no swaps. Did we have a swap in there? Yes. Right. Even though we know that's in order, we don't stop. Seventh time. 35, 23. 23, 20. 20, 18. 18, 17. 17, 16. Blah, 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 blah. Did we swap anything? No. Sort. Complete. Guys, please check. I do think some of you stopped after 6 and I've given you the full marks. Be honest, who's lost a mark here? So some of us did 11, okay? That's okay, the mark scheme will allow it. And that is because in a list of n numbers, we know the total number of passes is n minus 1. That's a fun fact that you may need for your next exam, isn't it? Okay? They also accept that. So just know, no matter what you do, that is okay. Right, the next part of the question says, use the first fit decreasing bin packing algorithm to allocate the parcels to the containers. Now, first of all, I've seen a question in a previous one where we had to sort it in increasing order and then it said first fit decreasing. So let's just double check though. This says decreasing and our list is decreasing. So we can use that list. Yeah? In the previous paper we did last week, it's told us to sort the list in ascending order, but then told us to do decreasing. So we had to flip it ourselves. Does that make sense? Yeah, in this one, we've read the question. We can all read decreasing. This one's also in decreasing. So again, A, B. Now, guys, little clue here. If our lower bound was 4, once we've put them in order, we should get the lower bound. If you have not got 4, you know, you need to really think what's happening here. So, we start. Remember 45. So 35, it's got 10 left. 23, how much do we have left from 45? 22. 20 means I've got 25 left. 18, where does that fit? In the second one? No? Yeah, it can. Can 18 fit in that one? Oh, 22 could fit there. Why did no one tell me? 20 can fit here, can't it? And then I've got 2 left. 18 can fit in this one, and then I have 27 left. 17 can fit here, and then I have 10 left. 16 has to go here. And then from 45, that means I have 29 left. 13 has to go in this one. I've then got 16 left. 11 has to go in this one. I then have 5 left. Where can 9 go? In the first one, I have 1 left. Where can 6 go? In the third one, I have 4 left. Where can 5 go? In the last one, I have none left. Where can 4 go? In the third one, 0 left. Okay, can we see how we've done that? Everyone happy? Fantastic. Now, you know in most papers, there will be a quick sort or a bubble sort. With bubble sort, please write the passes down the side. With quick sort, please write the pivots. Okay? And remember about the n-1. And also, do you remember we looked at that question and it said, didn't it, give 2 conditions when bubble sort stops. Okay, it stops when there are no swaps made in a pass or if the list contains 1 number. Okay? Because if you have 1 number, can you swap it? No. So that was the 2 marks. It is a list, but it's a list of 1.
That's not a list.
Well, I'm not sure about the technical term, but that is what gets you 2 marks. It's still a list that contains 1. Can you have a bag of sweets that contains 1 sweet? Yes. It's still a bag of sweet. Okay, next question. Question number 2. Now, the first thing I should do when I look at this question is read it properly. The first thing I'm seeing is Cascade, and I'm like, yes! Because they're the easiest to draw, are they not? Yeah. Scheduling, that, on the other hand, is a bit difficult. So, here we can see a project is modelled by the activity network shown in figure 1. The activities are represented by the arcs, the number in the brackets in times hours. To complete the corresponding, each activity requires 1 worker. The project is to be completed in the shortest possible time. Complete diagram 1 in the answer booklet showing the early and event times. So we should be really competent at this now. We know the start node is 0. There's only 1 way to the second node, so that must be free. When I go to B, there's 3 ways into B, not into B, sorry. When I get to this one, there's 3 ways into here, so I best sort out this one first. So this one is definitely 2. Now for this one, I can either go 0 to 4, which is 4. 3 plus 0 is 3. 2 plus 5, 7. Which one do I pick? The largest, because it's 7. 7, perfect. Now, for this one up here, there's 2 ways in. I've either got 3 plus 5, which is 8, or 2 plus 7, which is? There is 3 ways. Oh my golly, there's another way here. Watch out for that. Okay, so then I'm going to have to do those ways. To get to here, there's only 1 way, is that right? So this is 14. Okay, so go back to this. 3 plus 5 is 8, 7 plus 2 is 9, 14 plus 0. Perfect, that's how we get 14. Watch out for that. Okay, how do we get into this way? 3 ways. 2 plus 4 is 6. 7 plus 6, 13. 14 plus 0, 14. Brilliant. Okay, how do I get to this one? There's only one way in, is that right? Through J. So that must be 20. How do I get to this one? There's 2 ways. 14 plus 8, which is 22, or whatever this is plus 4, yes? Okay, how do I get into this one? Now, if I look at this, there's 4 ways, is there not? 20 plus 4, 24. 14 plus 8, 22. 14 plus 4, 18. 14 plus 7, 21. 24 is the one. Now, we usually come out here, don't we? So that's a bit of a sneaky one. Please make sure you look at what's coming in and out of these notes. So lastly, I've got 24 plus 4, which is in fact 28. That's greater than 22, isn't it? Now, you're not actually going to believe how many people, when marking this, did not get full marks for this question. Okay. Now, we know this is the largest, so we're going to start at 28 here, aren't we? Okay, now let's go backwards. Now, as we go backwards, we look at what goes in. So the first one's really easy. This one only has 1 going out of it. So going backwards, if it's only got 1 going out, we just take it away. We get 24, yes? Okay, this one only has 1 coming out of it, doesn't it? So when I look at this one is also 24. 24 take away 4, 0. 20, okay. This one here, I can either do 24 take away 7, which is 17, or 28 take away 8, which is 20. Which one am I going to choose? 17. Because I choose the smallest, don't I? Is that all the ways? Yeah, that's all the ways. So that is 17. Okay. For this one here, what's coming out of it? It's this one or this one. And this one. Currently, I don't have all those 3, so I have to go back up to this one. Okay, this one has this and this coming out. So I've got 20 take away 6, which is 14. Or 22 take away 8 is also 14. Oh, sorry, that 24 take away 8, which is 16. 14 is the smallest. Okay, so I've got 14 take away 0, 14. 24 take away 4, 20. 17 take away 0, 17. Which one am I going to choose? 14. Perfect. Okay, this one's easy. I've only got 2 coming in. This one I've only got 2 coming in. So I am going to have to figure out this one first, aren't I? This one's got 3 going into it. So going backwards, 14 minus 2 is 12. 14 minus 7, 7. 17 minus 6, 11. The lowest one is 7. God, this looks so messy. Okay, 17 minus 5 is 2, or 17 minus 4 is 13. I'm going to choose 2. This one I've got 14 minus 5 is 11, or 7 minus 0, which is 7. So there we go, nice and simple. So there we go. Now, probably would have done a lot more of that in my head, but I just want to make sure we were all comfortable. Let's get rid of all of this random working out, because that actually confused me. Maybe once you do your working out, you should get it gone as well, because you're under time pressure. Did anyone work out like I did, or are you just doing it in your head and not writing it on here? Because then it looks a bit messy. Did it in your head? Perfect. Okay, so that was lovely. Now, so there we go. I don't know how many marks that gets you, but it gets you 4, which is nice. It then says draw the Cascade chart for this project. So here we go. Now what we've got to do is draw this. So if we come here, first of all, what are our critical activities? So as we know, critical activities is when, if we were to work out, if we did this minus this minus this, what do I get? 0, absolutely. Okay, so this is our critical activities, and this is what we're drawing. Whenever we draw, we're looking, this is our start time, this is our duration, and this is our finish time, okay? Now, between the duration and finish, that's when we do the dotted lines, if it's not the full time if it's not critical. For critical, there's not going to be. So for critical, if I have a look, oh, sorry guys, this is 0. So for critical, we get C, E, G, and then, now if we have a look, this G, some people are going to think, right, 14 plus 4, if 24 minus 4 minus 14 is not 0. Please watch out. Nearly in all the exams, the critical path includes going through a dummy, because this dummy is practically saying you can go from here to here. That's all it's saying. So now if we have a look, 14, 6 and 20, 6. Then we go down, N and P. So we can see all of our critical activities here, okay? So, 0 to 2, this is C, and then 2 to 7 is E, and then 7 to 14, what is it? G. 14 to 20, J. 20 to N, and then 24 to 28, P. Okay, guys, you have to do your critical path, and then now we're going to learn to, what are we actually going to learn to do? Does anyone know? Say the alphabet. Okay, what does the first letter in the alphabet say? A. So we start at A. So we start at 0, has a duration of 3. Okay, we start at 0, duration 3, and then the last one is 7. So dot, 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 A. After A, what do we have? B. Okay, starts at 0, it's 4 long. Okay, and I am using a ruler, and it ends at 7. Okay, if it was wonky, this is your eyes. This isn't my drawing. Okay, what comes after B? C, but we already did it. What comes after D? So remember for D, we start at 3, it's 5 long, and then we do the dotted lines to 14. Yeah? D. Starts at 3, it's 5 long, that takes me to 8, and then we do the dotted lines to 14. And again, I'm using a ruler, and this looks really, and if you want to, you can shade this to make it look like it's a bit thingy. So basically, what's going to happen is all as if this is going to be done. After D, what do we have? E. After E, F. Now, F starts at 7, it's too long, finishes at 14. F starts at 7, it's too long, and it finishes at 14. Okay, now, and then we carry on, and here's one I prepared earlier, as you can see. This is then how it should look, okay, because I can't draw this any longer. So here we go, perfect, and as you can see, these lines are straight. I was having a technical issue with my pen, so you can see they're a bit wonky. I have no idea why. Okay, so that's how we do part 2, okay, we've gone through, decided how to do it. Now, this is the part that I want to spend a bit more time on. It's 2 marks, and for 2 marks, sometimes it takes a bit longer than 2 minutes of brain power to do, okay? Some people started to try and schedule this because they thought this could be the easiest way, which is true, but then scheduling is difficult all in its own. It says, use your Cascade chart to determine the minimum number of workers needed to complete the project. So, once you've done this, what you need to do is you need to get a ruler. Okay, and you get your ruler, and unfortunately there's no easy way to do this but to do it this way. So everyone's happy this is my ruler? Okay, oh, that's just brilliant. So now with my ruler, if I put my ruler in between 0 and 1, how many boxes have I hit? 3. We're looking for the maximum number of boxes. Okay, this will give us our minimum. So, sorry, 1 second. Now, if I move my ruler here, okay, how many boxes do I actually have? 3. Even though it looks like 5, But when you can see, oh, sorry guys, I can't use the lightsaber at the same time as the ruler. Right, I'm just going to use colours. It looks like 5. 1, 2, 3, 4, 5. But it's not 5 because in theory we could do A and B at a later time. Does that make sense? We're looking for the biggest amount of solid boxes in one line. So if we keep going, if I go here, how many solid boxes do I have? 3 still. Yeah? I keep going. This one is just 2. How about this one? Okay, it looks like 5, doesn't it? I don't know what we're thinking. Bingo. We've hit 5. Okay. Now, this is where it gets tricky. We're thinking to ourselves, I know what's happening here. Oh, do you know who that reminds me of? I see what's happening here. You know what song? No?
Oh, wait.
Moana. Okay, anyway, let's get back to this. I'll play this song after. Right, so it looks like there's 5. Okay, so this is probably where it's going to be. So let's focus here where it looks like it could be 5. Don't let it trick you. Now, let's choose. So guys, choose a number either choose between 16 and 17. Okay, there's never point choosing. Can you see this is between 15 and 16, the first lot of 5? Yeah. There's no point doing that because if you notice with the boxes here, I'm going to have to get the saber out. If I moved this K that started here and here, there's no longer 5 in here. So we want to choose a number roughly between, I reckon it's between 16 and 17. No, between 17 and 18. Should we choose between 17 and 18? Right, so guys, we're looking between 17 and 18 now. This is all about looking with your eyes. Can everyone open your eyes? Everyone can see? Yeah, of course you can. Right then, we're ready. So between 17 and 18, we're saying in between here, some of you are saying 5. Yes or no? Who said 5? Okay, you are incorrect. Let's look at why you're incorrect. So, you say 5, I say 4. Here we go. First of all, K. Oh. Okay, pretend that's a square, guys. So, imagine this is a square. K, we can actually move here. So, hold on. K is a definite in between 16 and 17. Do we agree or disagree? Yeah. Perfect. Okay, let's make sure we get a square this time. I don't know where that came from. Well, it's a rectangle. Okay, L. Okay. L, guess what, guys? L could be moved here. Is that in our 5? No. See how they're trying to trick you, right? But we're not gonna go down for that trick. M is this. If I move M, is it still in the 5? Is it still in our line? Yes. And then Q. I mean, even though this is really wonky, I don't know who drew this. And Q. I'll just make it a little bit bigger, I don't know what happened. So Q's here, and if I move Q here, oh, what do we see about Q? It's out. So have we reached, so technically, in between 16 and 17, what does that mean? 3. Doesn't it? After all that work, guys, honestly, this is a hard 2 marks in terms of looking, yeah? I haven't found an easier way to do this yet. If I do, I will tell you.
I answered 4 workers and only got 1 mark.
Yes, because you didn't write why. You didn't write the... Guys, sorry. Some of you got 1 mark for writing 4. You got the other mark for writing which 4. For which 4. Which 4 have to be happening. Which 4? We don't know yet. We've only found 3. We've got to keep going with this ruler. Right? Personally, is it between here then? Right, let's try this. What are we saying? Between 21 and 22? Right, let's do this one. We know it's 4. Okay, now let's start moving some shapes. Okay, if I move this, no matter where I move it, it's going to be in between there, isn't it? Right, so Q's in. Wait, what?
Yes, you can do 18 and 20.
Okay. This one. Oh. Okay. Sorry, guys. Right, let's start again. Let's do the green ones. Right, let's see. This is this long, yeah? Right, so this one is always going to be in that blue line no matter where I move it. Everyone happy with that? No matter where I put it. Okay. I'm just going to leave that there. Right, this L. This L, it can be out of that line. Are we happy? Okay. Then, this one, I have no idea what it is now. Because I've covered it up. This one is this long. No matter wherever I move this now, this is in the blue line. Yes? And we've just noticed that wherever I move Q, it's in the blue line. So it's between 21... Because remember, this is when we start the 21st day, yes? So it's between 21 to 22. So you know if it ever says what happens on the middle of the day of 21, at the end of the 21st day, the end of the 21st day is where 21 starts. Because remember, we start here after 24 hours, we get to 1 day. So if it ever says to you, do you remember what's happening between the 9th and 10th day? That means what's happening on midday on the 9th day? That's actually wait there. Yeah, it's actually 8.5. Because it's half, we go forward, don't we? That's if it's, we're completely off topic here. But do you remember if it says to you, what happens in the middle of the 9th day? We did a paper like that a few weeks ago. That is actually, the middle of the 9th day is in between 8 and 9. Because remember, the first day, middle of the first day is in between 0 and 1. Remember, it starts at 0. It really messes with your head, okay? Okay, so what we see by this is that we have 4 critical activities that have to happen at once. So you get 1 mark for writing 4, and then the other mark is knowing, so it's N. Does anyone know what number this was? Anyone know? I've put a box in front of it. K. Anyone know what box this one was? M. And what was this one? Q. Okay? Guys, obviously you're not going to have boxes. It's not going to be interactive like this. But I think if I rub these out, I rubbed the whole thing out. Yeah, oh my, see, I don't even know what's happened there. Right, so, let's just hope that you're right. So this is how I got N, K, M, and Q. Okay, so going back, so it might ask you to schedule it. You know scheduling's like pick and mix. It asks you which one's critical. We've just done that. What else do they ask you in these types of questions? Sometimes it will give you X and Y's here, won't it? And you have to work backwards. Just remember, if you know how to do this, you're okay. So here we have a flow chart. Now, as you know, we have not seen a flow chart for in an exam question for a while, have we? So is this the first flow chart in this exam series? Yes. It could be, yes. So this is an interesting one, really, because we haven't seen one, but remember, it is in the spec. And remember, with the spec, anything can happen. You've been given all the rules. You now need to know. So, an algorithm for finding the positive real root of the equation is described by the flow chart shown in figure 2. Use the flow chart. Start with A equals 1. Okay, so A equals 1. To complete the table in the answer book, start in values to at least 6 decimal places. Guys, can everyone read 6 decimal places? Yes? Can everyone read 6 decimal places? I'm unsure why some people's that I've marked had 3 decimal places. 3. It's like they can't count.
Miss, I've got 7.
Well, it says at least. So can we have 7 decimal places?
Yes.
Yes, of course we can. And this is great preparation for when we do the constraints. Right. Then it says, give the final output correct to 5 decimal places. So guys, this is the final output. It's the final output. Do-do-do-do. It's really important. I know we've not had much experience with these types of questions, but you need to put this final output for the final marks. Someone in this room did not get the final marks. They did not round to 5 decimal places or put the final output. Looking at no one in particular. So, part A. We put 1 in. Now, let's see what happens. I'm assuming I need a calculator. So, it says input A. We inputted A. Okay, we got 1 mark. You don't even get a mark for that. Right. Then it says B equals 12 minus. Okay, guys, I'm going to let you into a little trick. Do you remember we used to do, I don't know if we did it in the GCSE. In the UK GCSE, we do something called iterations, or maybe you did it in numerical methods. Right, I want you on your calculator to press 1 and then press equals. 1 and then press equals. Because when we do these types of questions, if it happens again, this is like an iteration process. So once you press 1 and equals, I then want you to write this into the calculator, because this is what's going to happen. It might work. B equals 12 minus 5 lots of answer. I don't even know if this is going to work. It's just something I would do. And then what to the power of that. So in my calculator, I'm going to write exactly that. 12 minus 5 brackets, answer. Whenever I substitute, I always use brackets, don't I? 8, close brackets to the power of the quarter. Now, guys, I'm being serious. That's exactly what I've written onto my calculator. Okay, so here, and this is, I'm not joking, here is a picture of my calculator. It's exactly what I've put. I'm going to write equals. Okay, now it's 0.96716. Wait, how many did it want? At least 6. 1, 2, 3, 4, 5, 8. Okay, I'm going to do that. Then it says, is minus 10 to the minus 5 less than A minus B? It's less than 10 to the minus 5. Okay, I'm not going to press equals again, okay, because I've now set this up, right? What I'm going to think about, what is minus 10 to the minus 5? Okay, maybe I have to set this up again. Guys, I'm going to set this up again. So on my calculator, I'm going to do minus 10 to the power of negative 5. Okay, and it gives me minus 1 times 10 to the minus 5 on my calculator. But do you know what? I'm an A-level maths student, and I did standard form in year 11, didn't I? So I know that this is saying minus 10 to the minus 5 is minus 0.12341. Yeah? Less than A minus B. Less than, and then what is this now? 0.1. So I need to know, if I take these away, is it going to be in between 0.000 I know that's not true, because 1 take away this, I'm going to have, because this is a 6, what am I going to have? 96. What's 1 take away 96? Sorry, what's 1 take away 0.96? We know it's going to be 0.04, isn't it? So I know I'm not even going to bother saying yes until this is a 99, and then I'm going to check it on the calculator. Yes or no? Right, so this is a no. Right, now guys, it now says, no, let A equal B. So for A, guess what we're going to write? What B was. And then, in our calculator, we already set it up. We did the 1 equals, didn't we? And we had 12 minus 5 lots of the answer. Okay, now the reason why I'm saying this is because you're going to get different figures. Over 8, all to the power of a quarter, yes? Now, I press equals, I get 0.967168. If I press equals again, I now get 0.972789. If I take them away from each other, I'm going to have 67 take away 72. That's not going to give me 001, is it? Guys, do you understand how I'm doing this in my head? What's 967 take away 972? I'm going to get 0.0045, roughly, aren't I? Or 4 something. Okay? So this is no. Oh, my golly. So then, what does it say? Let A equal B. So I'm going to write this down. 972789. And then guess what I'm going to do on my calculator? I'm going to press equals again, and it's going to pop out the next answer. 0.9718, and then it says 38, which I'm going to round to 34. But in my calculator, okay, I have the exact amount. If I take away 72, take away 71, I'm going to be left with 0.972, take away 971 is 0.001 something. Guys, we're still not there yet because I need a bit further. Can you see how I'm taking away this in my head? Just a simple place value. This is a no. It's a no from me. And then I write this down again. And then, guys, look, I press equals. And I'm not typing this in my calculator all the time. You know what I'm being? A smart mathematician right now. 71996. Okay. Now. So now, if I was to take these away, if I look, 9 take away 9 is 0. 7 take away 7 is like 0. 1 take away 1 is 0. 8 take away 9 is the fourth place here. 1, 2, 3, 4. I'm going to have a 1 here, aren't I? So, nope. And then 0.971996. Guess what I press again on my calculator? Equals. And I get 0.97196? 9. Okay, guys, if I was to take this away, 9 take away 9, 0. 7 take away 7, 0. 1 take away 1, 0. 9 take away 9, 0. 9 take away 6. What's that going to give me? 3. What do I want? 1. So? Nope. 0.971969. And I'm not sat there like an absolute fool in the exam taking away these numbers because I'm a mathematician and I can do this. Hands up, be honest, who was sat there taking numbers away? Right, let's be smart about this. Right, did you press equals? Did I press equals again? No. Right, press equal one more time. 0.97197. 3, I get 4 now. So it's 3, 5. Yeah? Okay, if I was to take these away, 9 take away 9, 7 take away 7, 1 take away 1, 9 take away 9. Right, I'm going to have a 6 take away a 7. Is that going to give me a 1? Now, I'm not sure how close is it going to give me. So what am I going to do now? Because I've got a 1, roughly, I need to check. Is that going to be a 1 or is that going to be like 16 that rounds to 2? I have no idea. So I'll do it. What do I find? Yes, is the answer. Okay, brilliant. Then it says, give the final output, 5 decimal places. So what do I do with a 6 decimal place number?
You just remove the last one.
I don't remove the last one. I look at it mathematically and decide if I'm going to round up or down. In this case, I would remove the last one. Let's not say that, okay? How long have I taught you for? We can't say stuff like that. Okay, so 0.97197. Now, that is worth 4 marks, and that has took me 10 minutes to do. Obviously, I was talking to you, explaining, blah, blah, blah. So, for part B, it says determine the set of values for A that cannot be used to find the positive real root of the equation using the flowchart. So for here, it says given the value of the input A is a non-negative real number. So that means it's a positive number or 0. Okay? Determine the set of values for A that cannot be used to find the positive real root of this. This is saying that we want 12 minus 5A, we want that to be positive. So if it was negative, this would give us a set of values of A which we cannot use. So we're going to say, when is this less than 0? Because we know that a positive divided by a positive is going to give us a positive. And when we do that to the 4th root, we're going to get a positive value, right? But if the numerator is negative, we know that a negative divided by a positive is going to give me a negative answer. Okay? So we just need to know what A cannot be. So it's when 12 minus 5A is less than 0. Okay? So 12 is less than 5A. 12 over 5 is less than A. So for any values where A is greater than 12 over 5, this will not give us a positive real root. Because if A is greater than 12 over 5, imagine we said A is 3. We're going to have 12 minus 5 times 3, which is 12 minus 15. It's going to give us negative 3, isn't it? Yeah. And if we have a negative 3 divided by A, we're going to have a negative number. If we have a negative number and we're doing it to the root of an even, because the fourth root is an even, we're going to get an imaginary number. Just like, we can't square root a negative. It's physically impossible. We can cube root a negative, but any root that's even, and that's really good. That would be handy also in like your pure. So question 4. Whilst marking this, what I realised is that for part A, even if you got that wrong, the rest were not dependent on part A at all, which was fantastic news, because it did mean that even if you didn't do part A, you could still achieve 11 out of the 13 marks. So what you should notice is whenever it says by inspection complete the 2 copies of the table of least distances in the answer booklet. Now, fun fact, when we are dealing with prims, the whole point of the prims table is that you will have a weight for every root. We can add imaginary arcs. So this is something to really take note of in the exam. If you're given a table and you've ever got anything missing, add them in yourself. Okay? And you will never, if you're ever given a prims table, the whole point of a prims table is we're saying that every arc connects to every other. We just make this up now. Now, using symmetry as well, you know that down this side of the table, these are symmetrical. Okay? In some of the papers, I really don't know why, this number was different to this number. I really don't understand, because this is CD and this is DC. It should be exactly the same. So and even though that you might think that's obvious, they might ask you, why is this one the same as this one? We have no idea what they're going to ask you, but we need to know all of these facts. So, it says by inspection, so let's have a look. So let's do AC first. So from A to C, by inspection, if we have a look, so we could do 17, 15, 19, couldn't we? We could do 25, 19. And that is where we got a lot of the confusion. A lot of people then put 44. Okay? But actually, if you look closely, we've got 25, 6, 11. And this is where we get 42 from. Okay? So, next up, we then have DC. So from D to C, we've got 15 plus 19, 23, 11. We could do like 33, 29, but that's not going to make any sense. So from D to C, is it 34 is the smallest? It's 32. Where's 32 from? 23, 15, 6, 11. Yep, 32. Amazing. Now you can see, because this is by inspection, it is really hard to actually know if you're correct or not. You've just got to make sure that you've tried every route, and you can use a pen or a highlighter to help you. Then lastly, we have FD. So F to D, 23 or 15 plus 6, which is 21. To me, I think that looks like the smallest. Okay, brilliant. Now that gets you 2 marks. I can't remember what it said on the mark scheme. I don't know if you got 1 mark for getting 1 right or 2 right. Okay. Right, next up. It then says, by starting at A, use the nearest neighbour method to find an upper bound for the length of Derek's route. Write down the route that this gives the upper bound. Sometimes we're not asked to write down the route, okay, but we are asked to write the route, and we need to work out the length. Some of us have worked out the length but did not write down the route. It's really important we read the question. So So when we are doing nearest neighbour, we can just use the table. Or if you wanted to add in the arcs and make this a complete graph, you can do this. By drawing this as a complete graph, 1, 2, 3, 4, 5, 6, 7, by drawing this as K7 and adding in all the weights, you could technically do that. It makes no sense to do that. So we are going to use this. So nearest neighbour, starting at A. So we start at A. The nearest place to us is D. So as you can see, I'm going to start writing A, D. So D is the second place. The nearest place to D is E. And it's really good to get into the habit of this. Then we look at E. The nearest place is F. I'm now at F. The nearest place is 11. Yep. Which is C. I'm now at C. The nearest place is 26, which is B. At B, I then go to G, which is 20. Okay, so now I've written this down. Remember, we then have to go back to A. Okay, we have to go back to A. Why do we have to go back to A?
Because it's the nearest neighbor.
Yeah, because it's the nearest neighbour, and we still have to make a route, essentially. Okay, so we go back to A, so A to D, 17. So I'm going to add these all up. 17 plus 20 plus 26 plus 17 plus 15 plus 6 plus 11. No, wait there a moment. Where was I at? G? Sorry, what's that? 41. That should be 41. Sorry, everyone. Okay, so now once I add that all together, I get 136. Perfect, and it is kilometres. Sometimes it might ask you to write the units. Just make sure, I just found that from the question. Okay, make sure that you are able to read the question and find the units. Okay, next up, part C. It says, interpret the route found in B in terms of the towns actually visited. So, what this is looking for, again, our favourite word is common sense. If we have a look, G to A is 41, but if we actually have a look at the graph, G to A is 45. So that means we haven't, when we have gone G to A here, G to A, what we've actually done is we have actually, to minimise the time, we've actually visited B in the process because we've done GBA. Okay? Now, how we write that down to get the marks, as long as we understand, in the mark scheme, it says, so in the mark scheme, you literally just get the mark for writing A, D, E, F, C, B, G, B, A. So just to know that they know and you know that you understand that even though we're visiting G to A, what we're actually doing is we're going GBA, because 45 is G directly to A. We're doing GBA.
Why?
Because that makes 41. 20 plus 21 is 41. And that's what it said. Because remember, when we do this, we look at the least distances. So this is why part A was important. How did we get 21 here from F to D? Okay, F to D, there is actually a direct route, F to D. That's 23. But when we're trying to configure the table, we're looking for the smallest. So even though we've done 15, oh no, let's not use pink for that. Even though we've done 15 to 6, that's 21, we don't write on there that this 21, even though we've said it's F to D, where is it? Here. Even though we've said F to D, we haven't actually said, well, actually this is FED. Fed. Yeah? We haven't said that. This is a presumption. So this, again, these are these skills that we need to know what's actually going on in the background. And that's going to allow you to get that 1 mark here. Okay, next up, we have D. So starting by deleting A and all of its arcs, find a lower bound. Now, as you noticed in that previous question, we didn't use the 42, 32 or 21. I'm going to now rub this away. Okay, and we know we don't need that for the rest of the thing. So it says by deleting A. So I delete A. Everyone's happy I delete A. And then now what I'm going to do is find a lower bound. So when I'm finding a lower bound, I'm going to use prims. Yeah? So let's start at B then. The smallest one from B is in fact 12. B, E. Okay? And then what do we have? 6. And that is E, F, which is 6. The smallest one now out of all three, because remember, we're not having to actually do nearest neighbour, it's just working out this way for a moment, is 11. CF 11. Then the smallest one is it 15? EF 15. Well, I've said EF, sorry, that was ED, wasn't it? D5, and then the smallest one now is 20. BG 20. Now we don't just stop there when we delete, because once we've deleted, we can add all that up, and now we need to add the 2 smallest arcs from A. So if I do this from A again, we're actually going to get BA, which is 21, and AD, which is 17. Once I add them up, I'm going to get a lower bound of 102. Okay, and that is in kilometres. Brilliant. That was 3 marks, so nice and easy 3 marks, really. Okay, now part E. So even though this is only a 5-mark question, I'm going to do a bit more discussion around this, because whenever we're considering pairings of relevant nodes, this is called route inspection route. Okay, so step 1, we are going to write down, so 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. That's not right, is it? I have only 1 pair of odd nodes. Brilliant. Okay, so this is where we think to ourselves, right, we've got 1 pair of odd nodes. People freak out. Let's not freak out, okay? We have 1 pair of odd nodes. But because it says we need to start at A, which A is even, okay, A is even and G is also even. Because we need to start and finish them, we know it's a fact. We can only start and finish at 2 different places if they are odd. We have 1 pair of odd nodes. It's called semi-Eulerian. Do you remember? Yeah? So we need these to be odd. So this becomes our pair, as well as C and E. So AG we want to be odd, and CE they need to be even. Okay? If we want to start and finish at the same node, we want everything to be even. Yes? Perfect. So what we're going to do is look at the combinations. We've got AGCE, I've got AC and GE, and then I've got AE and CG. So I've got 3 different pairs. So now what I need to do is have a look at the pairs. So AG is, we know that is 41. CE 17. Does anyone know why this question is now really easy? Because we have the matrix. And what is the point of the matrix? It gives us the shortest route. Okay? No, sometimes they don't, but this is the beauty of this question, is that we have 5 marks and this is what we're doing. Okay, so AC we know is 42. And some of us, what I don't understand is how some of us got 42 here and then failed to write it in here.
I didn't know that they were asking.
Because that's what part A wanted.
Yeah.
So it seems a bit silly, really, that you've already done the work. GE is 32. AE is 25. CG is 46. Another thing to note is, this is literally all we're doing is reading off this graph. So those of us who did not get this right, it's a bit concerning that we can't read, really. So 58, 71 and 74. So which one are we going to go for? We always go for the smallest. So 58 is the smallest. Now it's really important that we write down the pairings that we are going to traverse. So if we look at AG, now this is where it gets even simpler. We can see from part B that it tells us what we need to know. So we knew that actually from G to A, that was actually GB and BA. Now from C to E, if we have a look, it's not 19, it's 17. And we can see that we've got to go to F. So that's CF and EF. Okay, so the ones we're going to traverse twice are these ones here. And you have to actually write that. You have to write them. You can't just put GA, because there is no GA. We have to write down what is GA. GA is GB and BA. We can't put GBA either. We have to physically write down the ones we're traversing. Now, I was looking at a question where it said, once you got this, it said, for example, given that we have to start at C. It says given. Okay, so guys, this is not part of this question. So this is not part of this question. It's a made-up question, but I've seen it and I thought it was a really cool one. It says given you can start at A and finish at any node. So you can start at start at C and finish anywhere. Finish anywhere. That's not how you spell where. There we go. And finish anywhere. So given you can start at C and finish anywhere, and you want to do this in the shortest amount of time, what are you going to do and why? Pause this video, you've got 2 minutes. Okay, so we're back again. So it says given you can start at C and finish anywhere. What does that tell us? That tells us that C has to be odd. Okay, now we already know from here that C has to be odd. Okay, so we know that we're not going to traverse anything with C in it because C needs to be odd. So we don't care about anything with C in because C has to be odd. Okay, so we're not looking at those. What we're looking for now is which one is the smallest out of the other pairings. That is AE at 25. So that means we are going to traverse AE. Now, lucky for us, AE being 25 is actually it is what it is. It's just AE is 25. That it wasn't ADE or anything, it was just AE. So that means we're going to traverse 25. So the total weight is going to be 291 plus 25. Which is going to give us 316. Okay? So you need to just use common sense here. Yeah? So I'm going to explain that again in a slightly different way. So here we go. The question says, given you can start at C and finish anywhere. If we start at C and we finish anywhere, okay, let's say anywhere else just to make this less ambiguous. If we start at C and can finish at any other node, but both C and the node we choose have to be odd. Because that is the only way, the semi-Eulerian graph, yeah? So, if I look here, when I paired CE AC, and CG. When I traverse these lines, this would then make C even. Now, we don't want C to be even if we're going to start at C and finish somewhere else. So I don't care about those because that was making C even. So now I look, right, out of the others, C will still be odd. Which one's the smallest? That's how we do it. Is that better? Perfect. So not many people got full marks on this question because of the worded part. Now, it says a lot of things, but basically we've got to use Dijkstra's, okay? And then it says to find the shortest route between A and J and A and K, state with reason which vertex should be chosen as starting vertex for the algorithm. This is something I tried discussing with you the other week. So, you know when it says, we always have the questions, it says find the route. Here we go, look, we can even see it here. It says find a route of minimal length that goes from F to H via A. Do you remember what the whole point of doing Dijkstra's is? If we start at A, the whole point of doing Dijkstra's is that Dijkstra's gives us the shortest route from A to any other node. So why would we want to, it says state reason which vertex we should be chosen. Well, it should be at A because both the routes contain A. And the whole purpose of Dijkstra's, and you should write, both routes contain A. And it's because that's the whole point of Dijkstra's. We start at A, and it gives us every other one. Now, some people couldn't count to 10 on here. We had 1, 2, 3, 4, 5, 6, 7, 8, 8, 9. Now, that's definitely not how we count to 10. We count to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So I'm not sure, some people, they I don't know why they let things confuse them. They just do. But it's okay. Right, so, guys, I don't know how this is going to work, but I'm doing this upside down. I'm really sorry. I don't know how to turn it around. Okay, so A, tell me if this is really annoying. A is the first place we visit, and this has 0 weight. Is this annoying if I do that on the side? Okay, I don't know how to rotate yet. Okay. Wait there. The only thing is snap rotation. Like, this is the only thing I don't understand. Flip right. Ah, there we go, guys. It's all right.
She can zoom in.
Here we go. Right, so yeah, so from A, we can then go down to B, which is 32. From A, we can also go to C, which is 12. I mean, we can go to J, 84. And we can also go down here as 24. This is always step one. We start at A, and we say, where can we go from A? Okay, and you can see from A, there's 4 different places that we are connected to. You have to do this. You need to show the method marks of cancelling down here, or else you're not going to get the full marks. So, where now is the lowest working value? That is 12, isn't it? So this is the second place we visit with 12. Now we're at C. From C, where can we could go? We can go down to D, which is 11. So 11 plus 12, 23. That is actually smaller. From C, we can go to G, which is 12 plus 31, 43. And then from C, we can go to F, 12 plus 39, 51. Now from here, I say to myself, where is now the smallest working value? Working values, remember, is here. 23 is the smallest, so guess what? That is the third place I visit with a total of 23. From D, where can I go? I can go to B. 23 plus 8 is 31, and that's smaller than 32. That's why I crossed it out. 23 plus 20, 43. 23 plus 32, 55. 23 plus 69, 92, 23 plus 17, 40. And that's all the places I could go from D. So, I don't even know where I am now. Oh, the next smallest place is B, 34. So that's the fourth place, guys. Remember, 4 comes after the number 3. Okay, 31. The only way we go from B is to E, it's 41. Now, the next smallest one is G. This is 5. It doesn't matter that we can't get from 4 to 5. That's not what this is about. That's not what the algorithm does. What the algorithm does is it tells us the shortest path from A to any one of these. It doesn't matter about the sequence of this. And that's going to be 40. Now we're at G, we go up. This is going to be 48. 40 plus 42 is 82. 40 plus 49 is 89. And those are all the places I can go from G. The next smallest number is 41. So this is where 6 comes, because 6 comes after 5. It's 41. And from E, the only place we can go is H, which is 51. Now I have a look, and the smallest value is up here. This is 48, okay? Doesn't matter that we can't go from 6 up here, and this is something that I see in a lot, and it's a really annoying mistake because it means that you don't understand the concept of what's actually happening. This is the 7th place with 48. 48 plus 32 is 80. Okay. Now I have a look. What comes after 7 is the number 8. This is where 8 is. It's 51. 51 plus 30 is 81. I now look at my smallest values. I have 80 or 81. 80. What comes after the number 8, everyone? 9. Wow. Because you wouldn't think people did that. 9. And that has 80. Now from J, I can't actually go to K, so that's fine. So what comes after the number 9? 10. Brilliant. And that is 81. I cannot believe it, but this is fully correct. Okay? So please watch out for that, because you can lose some really awful marks. Okay, the next question is somewhere, but I've lost it. Oh, it's here. Okay then, part B, use Dijkstra's, and then it says you should state the roots and their corresponding lengths. So, this is where the magic happens. We want the root A to J and A to K. Now, I know from A to J, I find the J box, and whatever my total value, that is how long the root is. The root is 80, because this is the whole point of the algorithm. If we start at A, it tells us where to any other node. And then A to K is in fact 81. Now how do I find the root? Now that's a slightly different story. We work backwards. So if we're at J, we're at 80. How do we then, if we have a look, from 80 we can either go straight to here. If I take away 84, do I get to 0? No, so that's not what I did. If I take away 32, do I get to 48? Yes. So that means I go up to F. So far this is J, F, and all I do is write like I would in Arabic. Backwards, yeah? And then after F, what do I take away to then get to the next place? I take away 8, and I get to G. And then from G, what have I done? I took away 17, and that does give me 23, so that's D. And then from there, I took away 11, and I got to 12, which is C. And then from C, I took away 12, and I got to A. So there we go. There's my root. Can you see how easy that was to go backwards? I'm going to do the same now with K. So I'm at K. I'm at 81. What do I take away to get to the next stage? Because if you think, if I take away 69, if I follow this path, does 81 take away 69 give me 23? No, so that's not the right way. Has to make sense. Is 81 take away 30, 51? Yes, so I know it's that way. Now, if you ever have it where you have like 2 giving you the same answers, that means that there's 2 separate paths that could lead you there, okay? Or maybe you'll then find that after that path it doesn't give you an answer, so you have to go with the one before. Don't be freaked out by that. Then after this, where do I go? If I take away 32, do I get to 23? No. If I take away 10, do I get to 41? Yes. So this is what's happening. 41. Oh, I should have written these down right there. K, H, E. Then from E, I'm going to take away 10. Then I'm going to take away 8. D, and then I know from D it is this root, C, A. There we go, nice and simple. So, really easy. And that is going to give me 7 marks. It then says, Tamasee's brother lives at F. Where on earth is F? Here. Okay. And he needs to visit Tamasee at A and then visit their mother who lives at H. So we need to go to F to H via A. So it needs to be F, H something. Now, lucky for us, I know exactly how much this is going to be. If we're going from F to A and then A to H, well, if I have a look, this is the same. So A to H is 51, and F is 48. So this is going to give me a length of 99, because that's exactly what's happening here. A tells me, and because A is a point in there, I can figure that out. We have to go via A. Now, from A to H, believe it or not, when you went to from A to K, you actually did A to H. Okay? So just use what you did earlier. And you already did A to F when you did A to J. That's the whole point. Honestly, they're so clever in these exams. So F, G, D, C. Can you see F, G, D, C, A? Yeah? And then from here, A to H, A, C, D, B, E, H, A, C, D, B, E, H. They very rarely, in decision exams, give you something that you're going to have to work out again because it's time. Now, be honest with yourself. Hands up. Who, for 1 mark, sat there and probably spent a little bit more than a minute trying to figure out the roots and not using what they already did? Thank you for being honest. Okay, so question 6. Before I attempt this, I want you to actually have a look at what's happening here and give it a go. So pause it now and start drawing the activity network for the precedence table. If I call it precedent table, it's my funny English accent. Right, well done everyone. So first of all, I'm going to show us an example of a completely incorrect one, because it's always good to look at incorrect ones so that we can see what's going on. Now, first of all, there would be no need, when I'm looking at this, it was quite a hard mark scheme, but also you've got to think, the first thing I'm spotting is, if we have here, from this node to this node, we have here E, and then from this node to this node, we have nothing, okay? That is literally, guys, this is the reason why we draw in pencil, we can rub it out. That is just 1, isn't it? Now, what you then notice is that for E, we would then have to put a dummy in here because we wouldn't be able to do the same for D. F, again, from F, we can go here, we can go straight along to here. So this is like what not to do. And as you can see, from H, we see we've got H, and then here we don't have any letter onto the arc. So top tip, if you have an arc, like we do here, and there is no letter, you have to think to yourself, is it going to be a dummy or not? And if it's not going to be a dummy, then you shouldn't have it there. That is like a tip. You should never have an arc that does not have a letter attached to it. Now, something else we have to look at is, remember, if you were given this network and then you had to draw the precedence table after, does it make sense? For example, is G dependent on C? Yes. Okay, it is. If, however, this dummy was facing the other way, like this would mean that G is dependent on B and C. So we have to be really careful, okay? So, what is going on? I don't know what's happening here. Right, brilliant. Okay, so that is just some nice hints for you. It won't let me rub it away. It's okay, we'll just leave it there. Right then, so let's actually begin to draw this. So we know that A, B, and C are not dependent on anybody. If they're not dependent on anybody, we're going to start the start node, okay? And we're going to have A, B, and C. Now, we have to remember, So now D and E are both dependent on A. So what I am going to do is D and E. Now remember, I am drawing this in pencil because as we know, sometimes the direction of this changes. Okay, and then we have F is dependent on A, B and C. Now, because it's dependent on all three, I am going to do some dummies. B's in the middle, so I'm just going to hope that this is right and go for the best. It normally is. So F comes out from here. It then says that G is dependent on C and C only. So actually what I did here was right. Because if G comes out of here, it is only then dependent on C. And then we have H is dependent on G. Well, that's nice. And then we have D, E, F, H is dependent on I. D, E, F, H. Okay, so all of these now are dependent on I. Okay, well, this is easy. I can delete this. And there we go. So that's easy. I'm going to move E. And make that go to F. Brilliant. Now what I noticed about D is because D and E both are dependent on A, they can't both now go to H. It's not allowed. So I have to use dummy. Okay. So there we go. This is a dummy. Now from here, I is dependent on this. So that's fantastic. I. And then from I, we have J, K, L. J, K, and L. And then we have M's dependent on L, but we don't have anything else. So I'm going to put M dependent on L because it's going to go up here. And then J still needs to connect. Now this last node here is our sync node. This is the last node. So J will need to be connected. It will have to be another dummy. So there we go, nice and simple. Now, it says state by which activity is guaranteed to be critical given a reason for your answer. So what made me laugh when marking this is some people had written this needs to be critical and then it says write down the critical path and they didn't even use that letter in their critical path. Okay, that was really funny for me to watch and mark. Thank you. So then, if we have a critical activity, what actually has to be critical? It's an activity that we have to, no matter what, wherever we start. Remember, we're going to start at the start node, we're going to finish at the sync node. It's a critical activity if we have to go through it. Now, I don't know about you, but how do we get from this side to this side? We have to cross the bridge of I. So, of course, I has to be critical. There is no way you can start here and finish here without having I in that sentence. Okay? So, state which activity is guaranteed to be critical, I, and then you can write something about that every path will include it. And that's a really nice one. In the mark scheme, it has different things, but you just know that you have to get from one side of the activity network to the other side, you have to go through I. Then it says it is given that each activity in the table takes 2 hours to complete. Okay, so imagine each activity taking 2 hours. Yeah, this is what it's saying. It's state the minimum completion time and write down the critical path of the project. Now remember, the critical path is the longest path, and we figured that out the other day, didn't we? Okay, that was like a top tip. So the longest path, so you can see here I've got 1, 2, 3, 4. Okay, so then I could do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, 6. I don't think I'm going to beat 6, am I? And I've got 6 by going 1, 2, 3, 4, 5, 6. So if each one takes 2 hours, 6 times 2 is 12. And we've done C, G, H, I, L, M. Okay, now remember I stated that I is a critical activity, so I does have to be in my critical path. Okay? So, when you look at this question, you probably think to yourself, right, what on earth is going on here? Because in the question booklet, you've got a graph, you've got inequalities, and now you've got a network. When have you ever seen a linear programming question that contains a network? Never. Okay, and this is what I was telling you, everyone. Each year they bring out something completely different and new. Okay, so let's go through the question. Figure 5 shows a weighted graph that contains 12 arcs and 8 vertices. Okay, I think this is important. I don't know why, but it just seems strange they've told us that. It is given that no two arcs have the same weight. Okay, so 4x plus 1 does not equal 2y minus 2. 4x plus 1 does not equal 8x minus 3 if they're all individual. Everyone happy with that? X and y are positive. Okay. X and y are positive. Please make sure you write this down. Okay? They're positive. Arc CD is not the minimum spanning tree for the graph. Okay. So this is not in the minimum spanning tree. What do we know about, first of all, what is a minimum spanning tree?
It's the minimum spanning, like adding.
It is a minimum spanning tree.
No, isn't like you add one.
It's a connected graph.
It's a connected graph which has the minimum weight. So how else could we connect D to any other? D only has two arcs coming out of it. So from this fact, this is actually saying then that AD, okay, must be less than CD. Now, I haven't even read the rest of the question yet. I'm just trying to interpret what that information means. Yeah. Okay? This is fact.
Oh.
Because the only way to connect D to the rest of the graph, there's only two routes. We can either do AD or we can do CD.
But you choose the lowest one.
We choose the lowest. And if CD was not chosen for the minimum spanning tree, we've chosen AD. That means that this is lower than this one. So can you see how this is a fact that we've probably studied in chapter 2? That they're now using on us. Anything that was in that book and in that syllabus, they could use on us at any point. Just because you don't see it in an exam question often, it doesn't matter. Okay? So, then it says, explain why y is less than x plus 7. Okay, I'm assuming it's got something to do with that. It's just an assumption. I actually have no idea. So let's just see if that works. AD, 3y minus 7, is that less than 2y plus x? So then I'm going to get y is less than x plus 7. Boom. Right, that is y. And you have to write on there because AD must be less than CD for the minimum spanning tree. I don't know what it says in the mark scheme, but basically we just explained it all, didn't we? In the mark scheme it says something along the lines of, if CD is not in the tree, then AD must be, as these are the only two arcs incident to D, or the weight of CD is greater than the weight of AD. Oh, so you can write one or the other. So you get 1 mark for an explanation. You could just write that and that. Yes. Okay. It then says, it is also given that when Prim's algorithm starting at A is applied to the weighted graph, AB is the first selected arc. Think about Prim's and think about what we know about Prim's. Starting at A, if this was normal, if this was Prim's, what would be the first thing we do? We choose the smallest one. So what does that tell me? That AB is smaller than AC. AB, wait, what? AB is less than AC. AB is also less than AE. AB is less than AD. I've now got 3 inequalities, haven't I? And this is using that fact. Remember, we go back. What does Prim's do? Like, take yourself, forget about the algebra. It's just there to confuse you sometimes. Think, right, if this was normal numbers, what would I do? Well, I would pick A, B, Y, because it's the smallest number. Yeah? Go back to that. So now we've got 3 inequalities that we can work with. And it says that show that y is greater than 2x and write down and simplify 2 further constraints. Well, isn't that lucky? I've now got 3 constraints. One of them is going to lead to y being greater than 2x, and then we're going to have 2 further ones. So let's quickly work that out. So AB, so we're going to have 4x plus 1. That's less than 2y plus 1. So we're going to have 4x is less than 2y, so 2x is less than y. Okay? This is actually the one that we've just shown. Yeah? Okay. The next one we have is 4x plus 1 is less than 8x minus 3. Okay, so we're going to have negative 4x is less than negative 4. So x is greater than 1. Yeah? Everyone happy how I did that? Because I'm flipping signs and doing all sorts in my head. Do you want me to explain that one? Oh. And then the last one, 4x plus 1 is less than 3y minus 7. So 3y is greater than 4x plus 8. I'm just going to do 3y minus 4x is greater than 8. And then I can use the finger method. We all know the finger method, don't we? Cover up. Yeah. Use your finger to cover up. Okay, brilliant. So there we go. Now I've got all these constraints. So remember the constraints I have. I've got y is less than x plus 7. I've just figured out this one. I've got this one. I've got this one. I know that x and y have to be greater than 0. And no two arcs have the same weight. So I know from that none of these were less than or equal to. Do you understand that? That's a really, so it says no two arcs have the same weight. So that's why all of these are not less than or equal to. Yes? Really important, we know that. And then it says represent these 4 constraints on the diagram. Now, some people couldn't get the inequalities, but what they did do was very clever. They plotted y and x plus 7, and they also plotted this one. You got a mark for each one. So even if you didn't do the constraints and you sat there, I have no idea to do this question, you got a graph, they already gave you some, just plot what's already there. There was 2 marks available for that. And you could have done that, okay? Don't just give up on a question because you have no idea what's going on. Just plot whatever's there, if you had time to spare, of course, yeah? Right, so let's actually use the ruler and start plotting these. So y is x plus 7, so from every one... Okay, right, so we need to draw, let's do this in... So we're going to do y equals x plus 7. So it's at 7, and then for every one across, we go up 1. Okay? So this is the first line we need to draw. So, once we've drawn that, we're then going to do the shading, okay? It says we want less than, so we're going to shade what we don't want, which is above. Okay, so that's that one done. Okay, the next line we're going to do, 2x is less than y. So it means for every one across we go up 2, one across up 2, one across up 2. Okay, and this is our next line that we have. Okay, it's going to look something... Sorry, mine's not going to be as accurate because... I don't know why it won't let me... There we go. There we go. And it says that y is greater than, so we're going to shade less than, because that's the bit we don't want. Okay? Right, now the next line is x is greater than 1. So here we have, this is the line, and we want it greater than, so we're going to shade what we don't want, which is on the left-hand side. Now the last line is the line that's causing some confusion, which is 3y minus 4x is greater than 8. I'm going to rearrange that to 3y equals 4x plus 8, y equals 4 over 3x plus 8 over 3. Okay, so 8 over 3, so we can plug in some values and see what happens. What happens when x is 0, y equals 8 over 3. 8 divided by 3 is 2.66 roughly, which is about there. Okay, and then let's see what happens when x is 10. What's 4 over 3? 40 over 3 plus 8 over 3. 48 over 3. What's 48 divided by 3? 16. 16. So that means we're going to have 10 and 16 as another point. Okay? So then it's going to look like this. Okay, now remember we want above the line, so we're going to shade below the line. So our final region is this region R. Okay, I'm just going to shade it in black. Here it is. There. This is the region R. This is the one we want. Okay, it then says, represent these 4 constraints on diagram 1 in the answer booklet. Check. There are 4 constraints. We've got 4 lines. Brilliant. So, and this one, there was the red line, wasn't it? It's really important if you are using colours to highlight which colour goes to which line, or you write down the lines here. It then says, using diagram 1 only. Okay, guys, so we're only going to use diagram 1. It says, write down the possible pairs of values that x and y can take in the form xy. So, that x and y can take this form. Now, remember, relating it back to the beginning of the question, it says x and y are positive integers, so we have positive whole numbers, okay? And this is only worth 2 marks. If we have a look, we can clearly see by the graph that here, here, and here, okay? Now, the only problem we have is, do we notice that none of these include? Can we see it doesn't include it?
Include what?
Oh, yes.
We didn't have, so do you know how we said that's important? So even though we would normally go for these, wouldn't we?
Yeah.
We can't include them.
It has to be within the region.
It has to be whole integers within the region. Guys, nothing I'm saying to you is by accident.
Less than. It's not like less than.
It's not less than or equal to. So that means our optimal points, this is where no 2 arcs have the same weight, comes in. Very crafty what they've done. So actually, these are the ones we can do. We can do this one, 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 and this one. So in actual fact,
Just whoever made the question like
1, 2, 3, 4, 5, 6, 7, 8. There are 8 answers we could have inside the region. Okay? Now,
what topic was this?
what do you mean what topic was this in GCSE? Reading coordinates. Okay, so you should have 3, 6, 7, 8 pairs. 1, 2, 3, 4, 5, 6, 7, 8. Okay, guys, in the mark scheme, they've got 9. Is there something I can't see?
You missed the top, I think you missed the one at the bottom.
Ah, here, guys, everyone look. I can see it now. It's this one right here. Now, this is a very sneaky question, but this is really good that we've had exposure to this, because if now you have a question where your inequalities are not equal to, you know that we're only looking at incidence values within the region. Okay, so the answers for part D are 2, 6, 2, 7, 2, 8, 3, 7, 3, 8, 3, 9, 4, 9, 4, 10, and 5, 11. Now you need to get all of them for the 2 marks. Okay? Okay, so Dami's point is really good. The lines I've drawn should be dotted, shouldn't they? Okay, now in the actual mark scheme, they've not referenced anything about dotted lines. Now, using the software that I've got, it's actually hard to do dotted lines with the ruler. method, as in, you know, when I put that ruler on. I can't do dotted lines, it's really difficult. But please bear that in mind, okay? But this is where it comes. No two arcs have the same weight. They've actually given us that piece of information. That's why our inequalities are not less than or equal to. Okay, sorry, sir, we've only got part C left to do. So, the minimum spanning tree for the weighted graph in figure 5. Sorry for that laughter that anyone might hear on this YouTube video. Right. Has a total weight of 73. 6 of the 7 arcs in the minimum spanning tree are AB. Where on earth is AB? Okay, so AB. Then we have AD. We then have BC. CE. EF and GH. Wait, what? Am I missing something?
It says 6 out of the 7.
Oh, okay, so it's either FG or EH or AG. Okay, that makes sense. Is that enough? Okay, so the question then says, because someone wants me to zoom in, the minimum spanning tree for the weighted is these. Okay, so guys, I've highlighted what it says, and I've looked at it, and I've immediately thought, well, hold on a minute, this isn't even a spanning tree. Why? Because they're not all connected. How can I connect GH with the rest of the world? Yeah, I can either do EH, GA, or GF. Now, guys, I've not even read the rest of the question yet, but this is all the things that are happening in my brain. I'm just word vomit. I'm telling you what's going on in there, okay? Then it says, it has a total weight of 73. Well, that's fantastic, okay? Has a total weight of 73. So we know the minimum spanning tree equals 73. Determine the values of x and y. You must make your method and working clear. Okay, this is a total 4 marks. Now, it seems a bit silly. So the first thing I'm going to do, okay, I have a long way to do this. It just doesn't seem worth four marks. Definitely something I am going to do is I'm going to add up exactly the ones I've got to see what an equation is. So if we have a look, I've got 3y plus 2y, 5, 6y, 6y minus 2y. Everyone happy? I've got 4 y's. Yeah? Then I've got x, 4x plus 3x is 7x, 8x, 8 plus 16 is 14x. And then I've got 3, 4, 2, minus 5. Everyone happy that that's my equation I now have?
Yeah.
This is 8 plus 16 is 14.
Wait there, let's look at the x's. Wait there, 4x plus 3x, 7x, plus 8x. No, plus x is 8x, plus 6. 8 plus 6 is 14, yeah? Everyone happy with these numbers? Okay. Now, we're now saying there's 3 options, essentially. Option A, B, or C. So I've got 4y plus 14x minus 5 equals... Oh, no, sorry. Plus... Now, I can either do y plus 1, because that's EH, isn't it? Yeah? That equals 73. Or I've got B, option B, I've got my 4y plus 14x minus 5 plus 2y plus 4. This could equal 73. Or I've got 4y plus 14x minus 5 plus 5x plus 1. This could equal 73. And is everyone happy that this y plus 1 is connecting it if I connected EH? This 2y plus 4 is if I decided to do GE. And then this 5x plus 1 is if I decided to do GF. Is everyone happy that's where these come from? Brilliant. Okay, let's zoom in again.
Well, don't you have to do simultaneous equation with all 3?
Well, no, I'm not doing simultaneous equations. What I'm going to do is, so I know I'm going to have 5y plus 14x minus 4 equals 73. So this equals 69. Yeah? Okay. And then I'm going to have 6y plus 14x minus 1 equals 74. Have I done that right?
Yeah.
Well, I don't think I did the first one right. Minus 5 plus 1 is minus 4. I need to add 4 on this side. This becomes 77. Yeah. It's alright. It's because this is a difficult question. And then we're going to have 4y plus 19x minus 4 plus 4. This one equals 77. Okay, honestly, I might be silly, but I'd start using all these pairs and see which one works. Now, this does not seem productive for 4 marks, does it? I don't understand. Right, can you believe this is what the mark scheme says? The mark scheme says that... Oh, I can't believe it, guys. We've added wrong somewhere. First of all, this should be 4. Did anyone check my adding? Oh, no, sorry, sir. Right, what is minus 7 plus 1 minus 6? Minus 2 minus 8. What's minus 8 plus 3? No.
Minus 4. Minus 5.
Yeah.
Minus 6 plus minus 2, then plus minus 8.
Wait, sir, can you just add this for me? Minus 7 plus 1.
Minus 6.
Minus 2
Minus 8.
plus 3.
Minus 5.
Exactly.
So what are you
Mark
trying,
scheme's wrong.
you're trying to add them together?
No, yeah. Okay, you're never going to believe it. The mark scheme then says testing integer value points, which is what I just said I would do for each of these 9 points. Now, apparently you test them all. I can't believe we're going to test them all. But we test them all, and the answer is x equals 3 and y equals 7. So the magic point is, in fact, this one. Now, what I'm hoping is you would have started from here and worked your way up, so you only test 4 lots of points. I can't believe that there isn't a quicker way. Sorry, guys, that's the only thing I've got. But well done. Good luck. Okay, so this is the end of the video. Just remember to read the questions. Everything that you need will be on that question. And if it's 1 or 2 marks, have a look at the ones before to see if you can use it. You've got this, everyone. Good luck.